Welcome to this video, Year 2 Core Pure. This is on complex numbers, and it specifically is on de Moivre's theorem. So de Moivre's theorem says that if you have a complex number written in modulus argument form, r cos theta plus I sine theta, and you raise the whole thing to the power of n, then that is equal to r to the n times cos of n theta plus I sine of n theta. Now we'll just see why that is, or prove that by writing r cos theta plus I sine theta to the power of n in exponential form. So r cos theta plus I sine theta to the power of n is equal to, well, we can write this in exponential form, so that is r e to the I theta, that's a bit inside the bracket there, to the power of n. And now we're going to say that this is r to the n times e to the I theta n, or I n theta. Now this step to go from here is using a result which is about powers, which is true for complex numbers the same as it is for real numbers, but which does need proof. So needs proof, and you can prove by induction. Prove by induction. And it would be a very useful revision and practice of your proof by induction to go and prove that this is equal to this. So to continue with de Moivre's theorem, so this is equal to r to the n times cos n theta. So we're going to, this is r to the n, e to the I theta n is cos n theta plus I sine of n theta, which is what we set out to prove. So it's really just 2 or 3 lines to prove that once you've got this result for indices with complex numbers. So de Moivre's theorem, we'll see, is very useful for proving trig identities, and also for using with series, complex series. Let's start off by answering some questions by using de Moivre's theorem. So question 1, we're going to simplify this expression, which has 2 complex numbers in it, to different powers. So the first thing is we're going to say that, well, the first thing to notice here is that the modulus of each of these complex numbers is 1. So we don't really need to worry too much about the moduluses here. So we can use de Moivre's theorem to say that this cos of pi over 8 plus I sine pi over 8 on the top here is equal to, well, it's modulus to the power of 6. Well, its modulus is just 1, so it will be 1 to the power of 6. Let's write it in this first line, times cos of 6 times pi over 8. Let's write that out as 6 pi over 8 plus I sine 6 pi over 8. 6 pi over 8 is 3 pi over 4, of course, divided by Here we want the power of 3, so we're going to have 1 cubed times cos of 9 pi over 10 plus I sine 9 pi over 10. Which is equal to, well, we've got one complex number on the top divided by a complex number on the bottom. Modulus is 1. So we're dividing so we can subtract arguments. So this is going to be, oh, sorry, we've got minus I sine 3 pi over 10 there. So this should be plus, actually, let's just write that in there, minus that. So we're going to put in one more step here. So we're going to say this is cos of 3 pi over 4 plus I sine 3 pi over 4 divided by cos of minus 9 pi over 10 plus, so we've changed the minus to a plus and we've changed the argument to negative I sine minus 9 pi over 10. Now what we want to do is, because we're dividing, we need to subtract the argument, so we're going to say 3 over 4 pi minus 9 over 10 pi is 33 over 10 pi. So this is now our modulus is 1, so we can leave that out. So this is cos of 33 over 10 pi plus I sine 33 over 10 pi. Now this 33 over 10 pi is bigger than 2 pi, so we could subtract 2 pi from it, and we're going to get 13 pi over 10, aren't we? So which is bigger than pi, so we actually want to subtract 4 pi from it. So this is cos of minus 7 over 10 pi plus I sine minus 7 over 10 pi. Second question, express minus root 3 plus I, the power of minus 2 in the form x plus iy. So what we're going to do is we're going to work out the modulus and the argument of minus root 3 plus I. So modulus of minus root 3 plus I is 2, and the if we just sketch a quick diagram, here's minus root 3 plus I there, I minus root 3, this is real and imaginary, so arg minus root 3 plus I is pi minus this angle here, which is tan the minus 1 of opposite over adjacent, so 1 over root 3. And that is, this is pi over 6, so this is 5 pi over 6. Now we can use de Moivre's theorem, minus root 3 plus I, the minus 2 is equal to, well, it's 2 times cos of 5 over 6 pi plus I sine 5 over 6 pi all to the minus 2, oops, which is 2 to the minus 2, oops, 2 to the minus 2 times cos of minus 10 over 6 pi plus I sine minus 10 over 6 pi, which is a quarter times cos of minus 10 over 6 pi is a half. No reason at all why you can't use your calculator to work out a value like that. And sine of minus 10 over 6 pi is minus root 3 over 2, so minus root 3 over 2i. So this works out to 1 over 8 minus root 3 over 8i. Right, that's the end of this first video on de Moivre's theorem. We'll go on to use that in more complicated ways in the next video.